Capital budgeting techniques. Dear friends, this video presentation is being developed in order to understand the concept of capital budgeting and the different techniques being used by companies in order to evaluate the different capital budgeting proposals. So this presentation includes the following. Number one, meaning of capital budgeting. Number two, the different types of capital budgeting. Number three, the features of capital budgeting. Number four, importance of capital budgeting. And number five, the various techniques of capital budgeting. Let us start the presentation by defining what is capital budgeting. Capital budgeting, which is nothing but investment of funds in long-term assets or long-term projects. The capital budgeting is defined as the company's decision to invest its current funds most efficiently in long-term assets in anticipation of future flow of benefits over a series of years. So in capital budgeting, the company is generally investing their funds in long-term assets and at the same time in anticipating the future benefits. And in the case of capital budgeting, you see that the projects are generally risky projects. Now, let us see what are the different types of capital budgeting. Capital budgeting can be classified into different types. So here the classification is purely based on its functions it performs. Number one, replacement projects. Number two, expansion projects. Number three, modernization projects. Number four, diversification project. Number five, new product development. Number six, R&D projects, etc. For example, a pharmaceutical company is proposed to introduce a new project or new medicine in the market. It costs around 200 crores. A company is proposed to construct a new building which costs about 10 crores. These are all some examples for capital budgeting proposal or capital budgeting projects. Now let us see what are the important features of capital budgeting proposals. Features. So when you see the different characteristics of the particular projects, the first feature is it is normally require huge investment. See, all the capital budgeting proposal generally needs huge amount of investment or massive investment or heavy investment. Number two, it is irreversible in nature. Once invested in capital budgeting proposal, is okay. You cannot revert back. Number three, it is risky because in the case of capital budgeting process, we are making huge amount of investment in anticipating the future benefit. It is always future is uncertain. It is risky in nature. Number four, there is a long gestation period, meaning that the time gap between the amount of investment made in different long-term project and the benefit received, it is normally very lengthy, right? So we have to wait long period of time. Number five, complexity. So all the investment proposal, it is very, very complex in order to understand because future is uncertain and future is risky in terms of different external and internal factors. Now let us see why capital budgeting is so important. So capital budgeting decision is very, very important because number one, it involves huge investment. Number two, it is risky. Number three, it is there is a long gestation period, and there is a permanent commitment of funds, etc. These are the problems generally faced by the capital budgeting proposal. But at the same time, there are a lot of benefits when you go for making investment in long-term projects. For example, the growth of any enterprise. The growth of any enterprise depends on how much investment made in long-term projects like expansion, modernization, etc. Number two, the profitability. The profitability of the company. Profitability of the company, it is also depends on how much investment made in different long-term projects. Number three, the value of any enterprise depends on how much investment made in the particular long-term projects. So, and you all know that the primary objective or goal of any financial manager is to maximize the wealth of shareholder. We call it as SWM, that is shareholders wealth maximization is the primary objective or goal of any financial manager. So in order to maximize the wealth of shareholders, it is necessary on the part of the company to invest more amount of funds in long-term project, without which you can't find the profitability, you can't find the growth, you can't find the value of the enterprise. Once you are able to maximize these, it is very easy for you to maximize the wealth of shareholder. At the same time, investment in long-term project which incurs huge investment, which talks about future, which talks about permanent commitment, there is a possibility because of these issues. Before making an investment, it is necessary on the part of the financial manager in order to evaluate the different proposal by using appropriate techniques. Now let us discuss what are the different types of techniques are available. Techniques of capital budgeting. The following are the major techniques generally used by the companies to evaluate the different investment proposals. Number one, payback period method. Payback period method. We call it as PBP, payback period method. And the second one is the net present value method. Net present value method. That is, we call it as NPV method. And number three, profitability index method. Profitability index, PI method. And this profitability index method, otherwise called as benefit cost ratio method, that is BCR method. And the fourth method is IRR method, that is internal rate of return method. So these are the different techniques are available. Now what is the use of these techniques? Why these techniques are being applied? What is the reason behind? Capital budgeting techniques are very much essential for every financial manager in order to check the economic viability of the project, whether the project is economically viable. To test the economic viability, we need different techniques. Number two, to know the profitability of the project, and to know whether the project be accepted or rejected, right? So whether the project be accepted or rejected can be decided based on the different techniques being used for different investment proposals. Now let us see each and every method, and each and every method, what is the definition of the method, and what is the formula is being used. Number 3, what is the example, what are the merits and demerits. Under this technique of capital budgeting, the first method is the payback period method. Meaning of payback period. Meaning. It is defined as the number of years required to recover the initial investment is called payback period. The payback period can be calculated by using a formula, payback period equal to initial investment divided by the average annual cash flow. This is a formula is being used. For example, a project needs an initial investment of 20 lakhs and it is expected to generate a cash inflow of rupees 5 lakh for the next 8 years, let us assume. So the payback period of this particular project is nothing but payback period will be equal to the initial investment is 20 lakh divided by the average annual cash flow, that is 5 lakh, which is equal to, that is 4 years. 4 years. So this formula can be applied only when the future cash inflow is uniform. When there is a uniform cash flow with respect to this particular project, the initial investment made is 20 lakh and this project gives you a cash inflow of 5 lakh for the next 8 years. So the cash inflow is uniform. At the end of the first year 5 lakh, second year 5 lakh, third year 5 lakh, goes like that. Supposing if the cash inflows are not uniform, say for example first year 5 lakh, second year 8 lakh, third year 15 lakh, like that, when there is a uneven cash flow, in such cases this formula cannot be applied. In such cases you should go for a method called a cumulative cash flow method. For example, supposing a project needs initial investment of 20,000 rupees. Assume at the end of the first year this project gives you a benefit of 6,000 rupees. At the end of the second year the cash inflow, for example 8,000. At the end of the third year this project gives you a cash inflow of some 5,000 rupees. At the end of the fourth year it gives you a benefit of 4,000. At the end of the fifth year the cash inflow is 4,000 rupees. So if you see this particular example, the cash inflow with respect to this particular project, by making 20,000 you will get uneven cash flow, not uniform. In such cases this formula cannot be applied. In such case what you have to do is, so this project, the economic lifetime of the project is 5 years, 1, 2, 3, 4, 5, it's a 5-year project, and the cash flow, that is cash inflow, at the end of the first year it is 6,000, at the end of the second year it is 8,000, at the end of the third year it is 5,000, at the end of the fourth year it is 4,000, at the end of the fifth year it is again 4,000. So now what is the cumulative cash flow, CCF, cumulative cash flow? At the end of the first year it is 6,000, at the end of the second year it is 6 plus 8, 14,000, at the end of the third year 14 plus 5, 19,000, at the end of the fourth year 19 plus 4, 23,000, and the end of the fifth year 23 plus 4, it is 27,000. So now what is the payback period? What is the definition of payback period? That is nothing but the number of years required to recover the initial investment. The initial investment is 20,000 rupees, right? In which year you will get this 20,000? So the 20,000 you will get after the third year, because at the end of the third year 19,000, at the end of the fourth year it is 23,000. So your payback period lies between third year and fourth year, because the cash flow is 19, and so your payback period 20,000 lies between 19 and 23,000. In such cases In such cases, the payback period will be equal to, at the end of the third year we will get 19,000. So 3 years plus. So in order to get your initial investment, we need another 1,000 rupees. That 1,000 rupees from the fourth year cash flow 4,000. So now 1,000 rupees from the 4,000. So 1,000 rupees divided by 4,000, which is equal to 1,000 divided by 4,000 divided by 4,000 will be equal to 0.25. So the payback period of this project is 3.25 years. So if in the case of payback period, if it is uniform cash flow, the formula can very well applied. If it is cash flow, in such cases this particular methodology can be applied in order to find out the payback period. And one of the advantage of merits of this particular method is it is very easy to calculate. It is a crude method of analyzing the capital investment proposal, but at the same time one of the basic limitations of this particular method is, if you see the first example, there is investment of 20 lakhs, it gives you benefit of 5 lakh for a period of 8 years, but the payback period is only 4 years. So the method does not consider the cash flow generated after the payback period. After the payback 5th year, 6th year, 7th year, 8th year, there are 4 years cash flow, it is not been considered here. And another thing is, this particular method doesn't bother about the time value of money, right? Doesn't bother about the future. Because of these limitation, demerits, we are going for modern techniques like NPV method, profitability index method and IRR method. So we will discuss one by one in detail. The second method is NPV method. NPV means net present value. What is NPV? NPV is nothing but it is the difference between the present value of cash inflows and initial investment and the company's opportunity cost of capital is being the discount rate. One of the basic advantage of this particular method is this method, the NPV is calculated on the basis of the present value. The time value of money is being considered as in the case of NPV method. There is a formula available to find out the NPV. NPV will be equal to cash inflow at the end of the first year divided by 1 plus k to the power 1 plus cash inflow at the end of the second year divided by 1 plus k to the power 2 up to nth year, the economic life, divided by 1 plus k to the power n minus the initial investment. So in this particular formula, NPV formula, NPV is net present value, C1, C2, C3, C4 up to Cn, the series of cash inflow in future, and this k is nothing but the cost of capital, that is the minimum expectation, the minimum rate of return expected by the shareholders or the minimum rate of return expected by the management. That is what we call it as cost of capital or minimum rate of return, or sometimes we call it as the hurdle rate or cut-off rate, and this C0 which is nothing but the initial investment. So in the case of NPV method, whatever the cash inflow in the future should be discounted to present value by applying this discount factor or cost of capital, and the cash inflow, the difference between the initial investment made and the sum of cash inflow, the difference is what we call it as NPV, right? So the NPV of any project, NPV of any project depends on 4 important factors. One is the initial investment, that is C0, initial investment, and the second is the series of cash inflows, and third factor is the economic life of a project, And the fourth one is the cost of capital. Cost of capital K, that is the minimum rate of return expected by the shareholder. Sometimes we call it as the discount factor. This is what in finance we call it as discount factor. And the initial investment, it is otherwise called as cash outflow or cash outlay. So NPV is nothing but it is merely a difference between cash inflow and outflow, right? Say for example, a project needs an initial investment of 40,000 rupees. It needs initial investment of 40,000 rupees, and the financial manager is anticipating a series of cash inflow for the next 5 years. Say for example, at the end of the first year, he is expecting some 9,000 rupees. At the end of the second year, the manager is expecting 10,000 rupees. At the end of the third year, his expectation is 11,000 rupees. At the end of the fourth year, the cash inflow expected is 12,000 rupees. At the end of the fifth year, he has expected 14,000 rupees. These are the expected cash inflow for the next 5 years for making an investment of 40,000 rupees. Now, it is quite obvious that the economic life of the project is 5 years, because the expected cash flow is only up to 5 years. So, N is equal to the economic life is 5 years. Let us assume the expectation of shareholders, the expectation of the management, it is being expressed in terms of cost of capital or discount factor. Let us assume K equal to 10%. When this is the situation, now the management is going to invest 40,000 rupees today, and the management is asking you, being a financial manager, whether this particular investment of 40,000 today, is it worthy? Is it worthy investment? Is it profitable investment? So, as a financial manager, it is your duty to forecast the future cash inflow, and he has to discount to the present value by using a discount factor of 10%, and finally you have to find out what is the NPV of the project. Supposing if the NPV of the project is positive, you may recommend the project may be accepted. If it is negative, the project should be rejected. Suppose if it is 0, that is a break even, you may accept the project. Now let us see how this particular project is. Calculation of NPV. So it is a 5-year project, series of cash inflows expressed in terms of rupees. At the end of the first year, the cash inflow is 9,000. At the end of the second year, the cash inflow is 10,000 you are expecting. At the end of the third year, 11,000, fourth year 12, and fifth year it is 14,000 rupees. Under NPV, the discount factor given, that is cost of capital given, is at the rate of 10%. So now this discount factor value, which can be calculated by using a formula, present value will be equal to whatever the future value divided by 1 plus k to the power n. This formula should be applied. This formula is a formula for calculating the present value, right? By supposing 1 rupee today, 0 means today 1 rupee, which is equal to 1 rupee. The value of 1 rupee today is 1. Supposing you will be receiving 1 rupee after 1 year. If your expectation is 10%, now this 1 rupee becomes, after 1 year, by applying this formula, present future value is 1 rupee divided by 1.10 to the power 1. Then you will get 0.909, meaning that if you have 1 rupee today, the value is 1 rupee. If you will be receiving 1 rupee after 1 year, at that time the value of rupee may fall into 0.909. At the end, supposing if you have 1 rupee at the end of the second year, then you will get 1 divided by 1.10 to the power 2, which is equal to 0.826. 0.826. At the end of the third year, the 1 rupee becomes 0.751 by applying the same methodology, that is 1.10 to the power 3, you will get 0.826. At the end of the fourth year, now the 1 rupee becomes 0.683. At the end of the fifth year, the 1 rupee value becomes 0.621, meaning that, so the future sum of the future cash flow to be discounted to the present value by the application of discount factor. So this value should be taken into consideration here. At the end of the first year, it is 0.909. At the end of the second year, it is 0.826. At the end of the third year, it is 0.751. At the end of the fourth year, it is 0.683. At the end of the fifth year, it is 0.621. So when you multiply the cash inflow and discount factor, you will get the present value of cash inflow. So 9,000 into 0.909, you will get 8181. 10,000 into 0.826, you will get 8260. 11,000 into 0.751, it is around 8261. In 12,000 0.683, and you will get 8196. And 14,000 into 0.621, and you will get 8694. Meaning that the future, supposing you will be receiving 9,000 at the end of the first year, the today's value is only 8,181. You will be receiving 14,000 rupees at the end of the fifth year. Today you are making an investment of 40,000 rupees today, and this 14,000 you will be receiving only after fifth year. At that time, the 14,000 rupees is being reduced to the rate of 8,694 because of inflation and other factors. So now the total PV, total present value of cash inflows, when you add all these, you will get 41,592. 592. So this is the sum of the cash inflow, present value of cash inflow minus the initial investment. Initial investment of this project is 40,000. So 41,592 less 40,000, you will get 1,592, that is positive. So the NPV, this is what we call it as net present value. So the net present value, which can be calculated by using the formula which I have already given, or you can use a tabular approach in the calculation of NPV. And you are aware that NPV is nothing but it is the difference between the present value of cash inflow and initial investment, and this NPV is, in this project, it is 1,592. So in this, to conclude, in this, if the NPV is positive, the project can be accepted. As far as this particular project is being considered, the NPV is plus 1592, which is positive. Now the project can be accepted. The project can be accepted. Now, what are the merits of NPV method? Following are the different merits. Number one, it uses cash flow information. It uses cash flow information, number one. Number two, it considers all the year cash flow. Unlike payback period method, doesn't consider the cash flow after the payback period. Whereas in this particular method, this method consider all the cash flow generated by the project. That is the major advantage of this particular method. Number three, it considers time value of money. That is TVM, time value of money is being, that is the reason why we introduce this 10%. It considers time value of money. Number four, it is generally consistent with the goal of finance, that is shareholders wealth maximization, and there is no bias in selecting the project. So these are the different merits, but at the same time there are certain demerits with respect to NPV method. See, the first demerit is it is very difficult to calculate the future cash inflows. The financial manager has to understand the concept of cash flow, how to calculate the cash inflow about the future period, and he has to apply so many techniques in the calculation of cash inflow, and determining this cost of capital is also very, very difficult, because the expectation of the management or expectation of shareholder is keep on varying or changing. So calculation of this 10%, it is also very, very difficult, and it is a tedious task. There are certain disadvantages, though there are certain demerits or disadvantages, and this NPV method can very well applied. It is the most classical method in evaluating the capital investment proposals. Next, let us move to the third method of analyzing the capital investment proposal, that is profitability index method, PI, profitability index method, and it is otherwise known as BCR method. BCR means benefit cost ratio, and it is a relative method of analyzing the profitability of any project, and it is just a extension of NPV method. The formula, so the definition of profitability index is nothing but it is a ratio between, PI is the ratio between present value of inflow divided by initial investment. Initial investment. So if you find the difference between these two, you will get NPV. If you get the ratio between present value of cash inflow divided by initial investment, you will get the profitability index or BCR. With respect to this particular project, the present value of cash inflow, which is equal to, that is 41,592, and the initial investment of the project is 40,000 rupees. So now the PI, profitability index of this project is 1.03. The rule, as in the case of NPV method, if NPV is positive, you can accept the project. If it is negative, you can reject. If it is 0, you may accept. Whereas in the case of a profitability index method, the rule is if PI is greater than 1, the project may be accepted. The project may be accepted. If PI is less than 1, the project should be rejected. If PI is equal to 1, you may accept the project. It may be accepted. Project may be accepted. With respect to this particular project, the PI is 1.03, which is more than 1, the project may be accepted. So in this case, PI and NPV gives similar results. Now let us discuss the fourth method of analyzing the capital investment proposal, that is internal rate of return, that is IRR method. So this method is defined as the rate at which the present value of cash inflow, which equates initial investment. This is equal to IRR. So IRR is nothing but the point at which, the rate at which the present value of cash inflow, which equates the initial investment. It can be written as cash inflow at the end of the first year, 1 plus k to the power 1 plus C2 divided by 1 plus k to the power 2. It goes up to Cn divided by 1 plus, this is the total present value of cash inflow, which is equal to the initial investment. What is the rate? What is the point at which the cash inflow which equals to initial investment? That is what we call it as internal rate of return, or the rate of return at which NPV equal to 0. What is the rate of return at which NPV is equal to 0? That is called internal rate of return. Now let us calculate the internal rate of return for the proposed project. a project needs initial investment of 40,000 rupees. It gives you a cash inflow of 9,000 at the end of the first year. At the end of the second year, it is 10,000. At the end of the third year, it is 11,000. At the end of the fourth year, it is 12,000. At the end of the fifth year, it is 14,000. IRR of any project depends on, the first is the initial investment. Initial investment. With respect to this project, the initial investment or cash outlay is 40,000 rupees. And the different cash inflows expected over the period of next 5 years is given, the second factor. And the economic life of the project, which is also 5 years. In the case of NPV, the cost of capital is given, the K is given, cost of capital. But in the case of IRR, your duty is to find out the value of K, the value of IRR. It has to be identified. This is the point at which your cash outflow and inflow both are equal. This is the point at which the NPV is 0. Now let us find out the method of calculating the IRR. There is no specific method in the calculation of IRR of the project. The method that we are using is trial and error method. Trial and error method of calculating the IRR of the project. There are different steps involved in the calculation of IRR. That is step 1. Factor to be located. To be located in the present value of annuity factor table. That is F equal to I by C, where F equal to factor to be located in your annuity table, and I equal to the initial investment, and C equal to average annual cash flow. With respect to this particular project, F equal to, we know the initial investment, that is 40,000 rupees, divided by the average annual cash flow. What is the total of this annual cash flow? When you total up all this cash inflow, you will get 56,000 rupees. When you add 9,000, 10,000, 11,000, 12,000, 14,000, all this, the sum of all the cash inflow, which is equal to 56. Now average, so 56,000 divided by n equal to 5, so divided by 5, which is equal to 11,200. You will get 11,200. This is the average annual cash flow. Now the factor to be located, F equal to 40,000 divided by 11,200, you will get 3.571. You will get this value. So this is the factor to be located in your annuity table. There is a table called the annuity table, that is for second stage. This factor to be located is being identified. It is very useful to identify the IRR, where the IRR is. So this is the table. When you see a financial management by I.M. Pandey, in the back side of the book you can find these tables. One table we call it as table D, that is present value factor of annuity table, where you can find the year and the different interest rate for various years being given. So when you see this particular factor corresponding to the economic life of the project, this 5 year, 5th year, you will find this value 3.571. You can find for 13% corresponding to 5th year, you will get 3.517. This is for 13%. So this factor is 3.517 for 13%, but our factor is 3.571. So our IRR may lies between 11 or sometimes 14, 11 and 14. sometimes 10 and 15. So, this particular trial and error method gives you an idea. So, our IRR may lies between 10% and 15%. Let us take 2%. The exact value of IRR may lies between 10 and 15. For these two percentages, you have to find out what is called as the present value of cash flows. Present value of cash flow has to be calculated for both percentages. First, let us find out what is the total PV of cash inflows for 10%. We know the methodology of calculating total PV of cash inflow. For 10%, the value is readily available for this particular project, that is rupees 41,592, which we have already calculated for the purpose of calculating the NPV. The value is readily available, right? You cannot repeat again. Now, let us find out what is the total present value of cash flow for 15%. For a discount rate of 15%, let us apply the methodology. The economic life of the project is 5 years, 1, 2, 3, 4, 5. The cash flow generated by the project for a period of 5 years, 9,000, 10,000, 11,000, 12,000 and 14,000. These are the cash inflow. And discount factor, here it is 15%. The value, the discount factor values, you can find, either you can go for calculating the discount factor by using the formula, or you can find from the table. There is a table called present value factor of rupee 1. This table gives you a value 0.870, 0.756, 0.658, 0.572 and 0.497. These are the values with respect to 15%. Then you can calculate the value, present value of cash inflow. You will get 9,000 into 0.870. You will get 7830. 10,000 into 0.756. You will get 7560. 11,000 into 0.658. You will get 7238. And 12,000 into 0.572, you will get 6864. And 14,000 into 0.497, you will get 6958. So, when you add all these 5, the present value of cash inflow, you will get total cash inflow. Total present value of cash inflow, you will get 36,450. When you add all these 5 present value, you will get 36,450. So, now the total PV of cash inflow for 10% it is 41,592, and the total PV of cash inflow for 15% it is 36,450. So, in order to find out the value of IRR, we need two values between 10% and 15%. So, the total present value for 10% is 41,592, which is more than 40,000, and for 15% it is 36,450, which is less than 40,000. Now, definitely you can find the value of IRR. So, now step 3, calculation of IRR. What is the PV required? The present value required for the calculation of IRR is 40,000 rupees. 40,000. Present value at the lower percentage of 10%. Present value at lower percentage of 10%. It is 41,592, and PV at a higher percentage of 15% is 36,450. Now, you find the difference between these values. So, the difference between 41,592 and 40,000 it is 1592, and the difference between 41,592 and 36,450, you will get 5142. So to find out this difference, you have to subtract 40,000 from this value. In order to find out this value, you have to subtract 30,450 from this 41,592. Now directly you can calculate the value of IRR. IRR equal to, among these two percentage, you take the lower percentage. One is 10%, another one is 15%. You take the 10% plus the difference between these two values, that is 15 minus 10%, that is 5%, the difference, into 1592 divided by 5142. This is equal to 10% plus 5% into, and value 1592 divided by 5142, you will get 0.309. You will get, which is equal to 10% plus 5% into this value, you will get around 1.545. You will get, this will be equal to 11.545 percentage. So this is your IRR. So the IRR of the given project is 11.545. So by using trial and error method, by using the table, we identified the value of IRR lies between 10 and 15%. So now your value, exact value of IRR is 11.545, and this value IRR is greater than. So the rule, acceptance rule is, if IRR is greater than our cost of capital K, the project can be accepted. In this particular project, IRR is 11.545, the K, that is expectation of shareholder, is 10%. So this is, so IRR is much higher than 10%, because 11.5 is more than 10%, so the project may be accepted. So with respect to this particular project, we applied all the three modern techniques. Payback period is a traditional method. This method doesn't consider time value of money, risk, etc. That is why we applied modern techniques. Number one, with respect to this particular project, we applied techniques. Techniques applied NPV, profitability index, and IRR. All the three methods being applied is, the NPV is plus 1592. With respect to PA, it is 1.03. With respect to IRR, it is 11.545. So NPV is positive, the project can be accepted. PA is more than 1, the project can be accepted. And IRR is higher than the expectation of shareholder, that is IRR is greater than cost of capital, the project can be accepted. So by applying all the three techniques, so all the three techniques conclude that this project is a worthy project. This project is economically viable and profitable project, and as a financial manager, with the help of this technique, with the help of analyzing this technique, the project can be recommended for implementation. That is the conclusion. Which is the best method? So we have studied 4 different methods. One is payback period method, other one is NPV, third one is PI, and fourth one is IRR. Among these 4, which is the best method of analyzing the capital budgeting proposals? Right? Payback period method is an easy and crude method, and PI method, which talks about the cost and benefit analysis of the particular project, and IRR, it gives you what is the safety margin, what is the break-even point at which NPV is 0. But NPV method is a very classical, it's a very the most important method. It consider, I told you already, it consider it uses cash flow, it considers all the year cash flow, and it is consistent with shareholders wealth maximization. It follows value additivity principle, all these things. So you can conclude NPV the best method of evaluating any capital investment proposal. Concluding remarks. One, payback period method. Payback period, you can use the formula initial investment by average annual cash flow. In the case of NPV, present value of cash inflow minus outflow, and it's difference between present value of cash inflow and outflow. Number 3, in the case of PI, which is nothing but PV of inflow divided by initial investment, or otherwise call it as cash outflow. Number 4, IRR. So IRR equal to present value of cash inflow, which is equal to initial investment. So the gist of all the 4 methods being given here. Payback method, the payback period can be calculated by using this particular formula, and the difference between the inflow and outflow is nothing but NPV, and the ratio between inflow and outflow is called PI, and the point at which inflow which equals to outflow, which is nothing but IRR. Among the 4 methods, and the NPV is the most important method in evaluating any capital investment proposal. Thank you.